What is A normal? What is the basic definition? A normal, what A normal says? A normal is equal to V square by R, where R is the radius of circular path. So what is A normal? K T square V square R. So what is V equal to? T into root KR. K is a constant here. Let me introduce. Okay, once you know tangential velocity, you can manage all the things. I'll differentiate this. dV is equal to dt root kr. So dV by dt equal to root kr. dV by dt is what? Tangential acceleration. So I know tangential velocity. So total acceleration vector A equal to an square plus at square. What is an? An is directly we know it is k t square whole square. A tangential root kr whole square. So this will become k square t to the power of 4 kr tan beta an by at. A normal k t square root kr t square. After this we'll calculate the omega. So we know v equal to this much, v equal to r omega. I'll substitute the value of v. T root kr equal to omega. So what is omega? T kr. Look at omega. It is this much. Omega is a function of time. What about the angular acceleration? So we know A tangential and I'll shift this one here. Then we know A tangential equal to R alpha. A tangential root kr. So what is alpha? Root of kr. So what type of motion it is? Uniform angular accelerated motion. So we can take help of the basic formula. So what is theta? Theta is equal to alpha t square by 2. So root kr t square by 2. So once you know theta, then number of revolutions you can bring it. So look at this. A normal, it is varying as a function of centripetal acceleration. Sir, how come centripetal? I will change it. So let's not bother about how that situation is brought here. Now let's just analyze. If the condition is given, if one quantity is given, how to predict other quantities. That's what I'm focusing here. Sir, again, what is the path? The path will be circular motion. Again, you need not to all the quantity, the same diagram. All the quantities as usual will show like this. This will be A normal, A tangential, A, this is alpha, this is omega, and this is beta. I think by this time everyone would have got the idea. Oh, circular motion. Okay, we can work out things like this. If somebody asks, what is the distance covered? What you are going to do here? dv, what v you can write it as ds by dt and carry on the problem. So don't get scared. Sir, here what is the distance covered? Or any other method of finding distance covered? Number of revolutions. If I get number of revolutions 4, what do you mean by that? 4 into 2 pi r will be the distance covered. I think this will be the better approach, no? So if you know number of revolutions, if you know it, then in each revolution, how much of distance it will cover? 2 pi r. So distance covered, can I find out by any other method? Yes, you can use this alternative method. Distance covered S is equal to number of revolutions into 2 pi r. In each revolution, how much? 2 pi r it will cover it. Total distance covered. This one alternative is going to help us a lot. And what is n? N is theta by 2 pi. So this will be root kr t square by 4 pi root kr. This you substitute here, you get the total distance covered. So what is n? N will be t square. See, anything they can ask you. In books, they just gave some limited ideas. But numericals, no, I can ask you anything. It's not that, so they should, so you better ready for everything. So distance covered, nobody in books asks. But in exam, I can ask you, what is there in that one? Of course, it's of no use. To test a student, like, can he analyze? I may test you like this, data. Look at here, centripetal acceleration, how it is. It varies with the time. The centripetal acceleration, can it vary with the distance covered? Yes, that is also